Okay guys, let's get started on our exam review. Going back to the beginning of the year when we learned about limits. So the limit is what's going on as we approach a number with the function. And in order to find out about a limit, we need to look from the left and the right of the limit. So we want to know what's going on as x approaches 3. We had some steps that we used to follow. And the first step that we used to do was we used to try to plug in. Step 1 was to plug in. And see what happens when you plug in. So let's plug 3 into this function right here. 3 squared minus 9 would be 3 squared, which is 9 minus 9 is 0, over, let's plug in 3. 3 squared, which is 9, minus 5 times 3, which is 15, plus 6 would give us 0 over 0. And that's not okay. Anything divided by 0 is not okay. So if step 1 failed, step 2 was to simplify. So let's go ahead and try and simplify this. That generally means factor, simplify algebraically, do something like that. So let's try and simplify this algebraically. This is a difference of squares. It's like a squared minus b squared. So we can factor this to a minus b, a plus b. So now we're going to take the limit as x approaches 3 of x minus 3 times x plus 3. And we're going to simplify the bottom. We're going to try and factor that. Two numbers that multiply to 6 add to negative 5 are negative 3 and negative 2. So x minus 3, x plus 2. Okay, cancel what you can. X minus 3 is canceled. And we have something simplified. We've got the limit as x approaches 3 of x plus 3 over x plus 2. Now that we've done step 2, we go back, we try step 1 again. We try to plug in. So if I plugged right into here, I'd have 3 plus 3, which is 6, over 3 plus 2, which is 5, 6/5. If that answer comes out as a real number, you're done. All right. Okay, next one. The limit as x approaches 0 of 5x over 3 sine x. Step 1, let's try and plug in. So if I plug in, we've got 5 times 0, which is 0, over 3 times the sine of 0, which is 0. Not okay. All right, so step 2, we try and simplify. Well, we can't really simplify this algebraically, but we could write it like this. As x approaches 0 of 5/3 times x over sine of x. That's okay. We haven't changed it. It's still a product. And you remember over here, we had learned a special rule that the limit as x approaches 0 of sine of x over x equals 1. That was like a special rule that we had learned. So we can actually apply that here. If you flip 1, it's still 1. So this really is just 5/3 times 1, or 5/3. All right, so that's a rule we definitely have to memorize. All right, next one. Limit as x approaches infinity. Now, infinity is a little bit different. We don't really like plugging in infinity, but we want to kind of know that this is, when we plug it in, we're kind of wondering what's going on with it. We're looking at its end behavior. Infinity, limit as x's approach infinity, is really talking end behavior. What's going on at the ends? And if you remember, end behavior is directly tied to horizontal asymptotes, right? Okay, horizontal asymptotes, end behavior, same thing. So there's a couple of rules for horizontal asymptotes. All right, so end behavior and horizontal asymptotes, they had those 3 rules. And really, you're looking for the term in the numerator that has the highest power, which is this one, and the term in the denominator that has the highest power, which is this one. And if those terms have the same power, then we take the coefficient in the numerator, which is -1, divided by the coefficient in the denominator, which is 2. And so that will be our limit. That will also be our right end behavior or our horizontal asymptote. Also, another thing that you can think of, if these terms are not the same power, if this power in the numerator is larger, then the answer either is infinity or negative infinity. If the one in the bottom is larger, then it's just 0. All right, so here is another example of that. Limit as x approaches infinity. We're talking end behavior. You're looking for the largest term in the numerator, largest term in the denominator. Here it exists in the numerator. Highest power is 3 in the numerator. So what would happen if we plugged in infinity in here? We'd have 5 times a positive number infinity cubed. And so that would just equal infinity. All right, let's look down here at E. We're doing the same thing. Limit as x approaches infinity. So we're talking n behavior. Highest power in the numerator x, which is 1. Highest power in the denominator is 4. So therefore it is quote unquote bottom heavy, which means that the limit is 0. All right, F. The limit as h approaches 0 of sine of pi over s(x) plus h minus sine of pi over s(x) over h. When you look at this problem, you're not really supposed to think about limits. I mean, you are because it's a limit, but you're more likely to think about the definition of the derivative. Anytime we have the function of x plus h minus the function of x over h, the limit as h approaches 0, that really means the derivative. So what is our function here? Well, that's our function right on the end, sine of something. So f of x is the sine of x. So this wants us to take the derivative of that function. So f prime of x will be the cosine of x. And what number do they want us to plug in? Well, that's right there, pi over 6. So f prime of pi over 6 is equal to root 3 over 2. All right. Moving on down, we go back to what we had before. The limit as x approaches 2. So this is a number. We're not talking n behavior anymore. We're talking about just approaching this number. We're going to try our steps. First step is to plug in. If I plugged in, I'd have 4 plus 4 minus 8. That's 0. Over 2 minus 2, that's 0. So can't do that. All right. Step 2 is to try to simplify. So let's try this. Limit as x approaches 2. I'm going to try to factor the numerator. I want two numbers that multiply to negative 4, add to 2. I think that's x minus, or x plus 4. And x minus 2, let me just check. That's negative 2. That's 4. So that would become 2x, and that's negative 8. Perfect. X minus 2. Cancel. Excellent. And now plug in again. Go back to step 1. 2 plus 4 is 6. That's the answer there. All right. How about h? H is this kind of crazy root thing. And we talked about this. Whenever you have a crazy root thing plus something else, or maybe in this case 2 roots, you have to use a special technique, which is multiply by the conjugate. The conjugate here is root x plus root a. Root x plus root a. I have to multiply the top and bottom by this number. Okay, so we're now doing the limit as x approaches a of, let's multiply this out. Root x times root x is x. Root x times root a is root xa, or ax. Negative root a times root a, negative root a times root x is negative root xa. Negative root a times root a is minus a. This term in the middle cancels. The bottom, I'm not even going to FOIL it out. Right now it's x minus a times root x plus root a. All right, let's look what we have in the numerator. Up top, we have x minus a, and we have that term in the bottom too. So we can actually cancel that whole term, x minus a with x minus a. Once this has happened, we can try and plug back in again. There's nothing in the numerator except 1. In the bottom, we have root x plus root a. If I go ahead and plug a in there, I've got 1 over root a plus root a, which is 1 over 2 root a. And that's my limit.